Okay, class. Where we stop? Kat sini betul? Betul tak kat sini? Mas kat sini kan? Betul tak? Das kat sini.
Wait,
Where we stop? Here, right?
chapter 5.
Can you see my screen?
Yeah, yes. This is
Can.
one.
Okay, so Wheatstone bridge application. Small changes in resistance are to be measured like in sensor applications. In transducer, Wheatstone bridge convert a resistance change to a voltage change. Combination of Wheatstone bridge with operational amplifier is used extensively in industries for various transducers and sensors to measure temperature, light, strain, and etc. Most commonly for measuring the strain gauges are used whose electrical resistance varies proportionally with strain in the device. So the most the most used application of Wheatstone bridge is in strain gauge, where resistance varies proportionally with strain. Okay, one of the most commonly used application of Wheatstone bridge is strain gauge. What is strain gauge? It is a simple metal conductor wire that tends to have an impact on its length, cross-sectional area, and resistance due to applied stress. When external forces are applied to a stationary object, stress and strain are the result. So it converts force, pressure, tension, weight, and so on into a change in electrical resistance which can be measured. Okay, this is the strain gauge. It is very small. In practice, the range of strain gauge resistance is from 30 ohm to 3 k ohms. The strain gauge is connected into a Wheatstone bridge. So the strain gauge may be applied to one arm or 2 or 3 or 4 arms of a bridge. Okay, one popular configuration of strain gauges and Wheatstone bridge is in weight scales. If the strain gauge is either tense or compressed, the thin wire of the strain gauge change in length, then the resistance can decrease or decrease. For example, when the strain gauge is stressed, the length is increased, the diameter decreased, so R is increased. Okay, because where is the thin wire of strain gauge? The thin wire of this is the thin wire or strain gauge. Okay, on strain gauge there are a thin layer. Okay, thin layer that will change in length when we apply stress on the strain gauge. So when we apply stress on the strain gauge, the length will increase. Okay, imagine that you have a rubber band. Okay, so when we apply stress or we pull the rubber, the length will increase, but the diameter will decrease. Okay, so the diameter can also be associated with area. Okay, A area. So when the area is decreased, R will increase. Okay. So L increase, of course R will be increased. This causes unbalancing of the bridge. Okay, So current, so when R is increased, the bridge will be unbalanced. Okay, instead of balance at the beginning, when we apply stress, the bridge will the resistance will increase, and then the bridge will be unbalanced. Current flows. So when the bridge is unbalanced, current flows through the galvanometer. This produces a voltage indication on voltmeter corresponds to the strain change. If the strain applied on a strain gauge is more, then the voltage difference across the meter terminals is more. Okay, as we learn on Monday, when the galvanometer shows current greater than 0 amps, so there is voltage difference across the terminal, right? If the strain is 0, then the bridge balance and the meter shows 0 reading. Okay, this is the second application of Wheatstone bridge loop test to find cable faults. Okay, the previously the application of Wheatstone bridge is strain gauge. Okay, so this is another application of Wheatstone bridge to find cable faults. Okay, so there are two. Find the fault location in an underground cable. To find fault location in an underground cable, so you will learn about fault. I think when you are on year 3 or year 4, okay, you will learn about fault. Okay, so there are two types of tests. Okay, so Murray loop test and Wiley loop test. Okay, so both tests are used to find cable faults in an underground cable. Okay, so the concept of this loop test is using Wheatstone bridge. You may watch this YouTube video to find out more. Okay, but basically, in Murray loop test, it is conducted to find the fault location in an underground cable by making one Wheatstone bridge in it. The Wheatstone bridge is kept in balance by adjusting resistance of the ratio arms R1 and R2 until the galvanometer deflection is 0. By comparing the resistance, the fault location can be found. You should use the known length of the cables in this experiment. Okay, so we put two arms, okay, A and B. Okay, adjusting resistance of the ratio arms 1 and R2 until galvanometer indicates 0. Okay, so we adjust R at A and B until the galvanometer reads 0. Okay, so this is balance condition for Wheatstone bridge. Okay, A over B is equal to R over X. Okay, so this is the point for fault location. Okay, so this is sound cable. Sound cable is healthy cable. This is fault cable, but this point is the location for the fault. Okay, so A over B is equal to, from this point to this point. Okay, so this is R, let's say R. Okay, this portion, okay, divided with this portion, okay, or this length, or this R. Okay, or you can write A multiplied with R. Okay, A multiplied with X, okay, is equal to R multiplied with B. Okay. Okay, more information can be found in this website. Okay, so this is Murray loop test. Okay, so we adjust R1 and R2 so that G will indicate 0 current. Okay, so this is in this figure AB X. Okay, so X is in previous figure, this X is equal to this length. Okay. This is good conductor. This is defective conductor or faulty cable. Okay, so this is the location for the fault. Okay, location for the fault. Okay, this is another figure, but the concept is the same. Okay, we adjust R1 and R2 until the galvanometer shows 0. So this is A until this point is represent as R here. Okay, represent as R. Okay, and Rx here represent X here. Ada lag. Okay. Locating a ground fault. So this is Murray loop test. Okay. Please do not memorize the notation of R3 and R2. Okay. You just refer to the circuit. The defective conductor of length LB is connected at its cable. Okay. Cable terminal to a healthy conductor of a length LE. The loop formed by these two conductors is connected to the test set. Bridge is balanced with the adjustable resistor R2. The ratio of R2 and R1 is generally known as the ratio arms. Okay, ratio arms. At balance, so we know that R2 divided with R1, okay, is equal to the green one. Okay, my cursor is stuck now. Okay, R2 divided with R1 is equal to the green path. Okay, divided with Rx. Okay, so the green path is RA plus RB minus Rx. Okay. 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 So in a conclusion, R2 divided with R1 is equal to the green one divided with Rx. Okay. The green one is from mana ni keset lain ni? Okay, I think you can understand. Okay, so the green one is from the end of the galvanometer, okay, or the end of R2 until the fault point, okay, the location of the fault. So RA, RB, and RS are the resistances of LA, LB, and LS respectively. Okay, maybe the question give the value of length in terms of length. Okay, L. So we can use that length. So RA, B, and S are represent or are the resistances of LA, LB, and LX respectively. Okay, so this is the derivation. Okay, we have we know that R is equal to rule length equal divided with A. Okay, so resistance is proportional to the length of the cable. Therefore, the value of Rs is proportional to the length Lx. Okay, so Rs is proportional to Ls. RA proportional to LA, and RB is proportional to LB. Okay, so from this formula, this is the general formula R is equal to rho L divided with A. Okay, where resistance is increased, so how about the A? Akil Ahnaf?
Decrease.
Decrease, Okay, so Abdullah Bassam, when R is decreased, how about the length? R decrease, how about the length?
Decrease also.
Tu siapa jawab tu? Siapa jawab tu? Who's answer?
Okay.
Akif juga. Oh, saya tanya orang lain, Akif juga jawab
Saya ingat saya lain.
Ha?
Saya ingat doktor tanya saya.
Ya ke?
Tidak rasa saya.
Okey. Sekarang ni berapa orang ni? Hmm. 39, okay. Mana Abdullah Bassam? Mana? Abdullah Bassam? Still MC? Anyone knows about Abdullah Bassam? Don't know. Okay. Omar, Muhammad, Omar, Al-Atas. When R is increased, so how about the length?
When R increase,
How about the
L
length?
will increase.
Again?
L will be increased also.
Okay. That's right. Okay, so if both conductors consist of the same material and cross-sectional area, so then we apply to this derivation, and LS is equal to this. So, and finally we substitute and we get this. Okay. There is another loop test. We call it S value loop test. Okay, you can just read this. Okay, in DC bridge, we have two configuration. Okay, one is Wheatstone and another one is Sami. Another one is how many configuration for DC bridge? Sami? Sami? How many configuration for DC bridge? Sami? Sami tak jawab Shazlina? How many configuration of this DC bridge? Shazlina?
Yeah, Doctor.
How many configuration of DC bridge? How many types? Tengok Nata. How many types of DC bridge? How many configuration of DC bridge in our syllabus? How many?
2.
Okay. Apa dia?
2.
Okay. Apa namanya? Hazlina.
Yeah.
Give the names of the bridge.
Okay. Sekejap.
Tengok atas lah.
Sekejap. Wheatstone dengan Kelvin.
Okay. Ada tak dalam lain nama Kelvin? Ada tak Hazlina?
Tak ada kot.
Okay. So this is another version, another type of DC bridge. It is modified version of the Wheatstone bridge. Namely as it is also known as Thomson Bridge. Okay, what is the purpose of this bridge? So, Wheatstone Bridge measure few ohms to several kilo ohms, but error occurs when measuring the low resistance. So, Kelvin Bridge is suitable for measuring the low resistance instead of Wheatstone Bridge. The resistance in the range of less than 1 ohm may be measured with a high degree of accuracy using Kelvin's bridge. Okay, so this is the explanation of Kelvin bridge. Okay. This is the derivation. Okay, the derivation of Kelvin bridge. Rx is equal to, okay, finally Rx is equal to R1, okay, or Rs R2, where is Rs R2? Rx R2 is equal to R1 R3. Okay, the same. Now we go to tutorial 5. Tutorial 5. Okay, so this is number 1, 2. 1 ke 2? Okay, this is number 2. Okay, this is number 2. This is number 2. Figure 1 shows a diagram of Wheatstone Bridge with constant of R1 equal to 100 ohm, R2 is equal to 1000 ohm, and R3 is equal to 200 ohm. Determine the value for the unknown arm R4 if the bridge is in balance. So we just use, okay, the formula for balance condition. Okay, at balance condition we know that R1 R4 is equal to R2, R3. Okay, R1, R4 is equal to R2, R3. So R4 that we want to find is equal to R2, R3 divided with R1. We just substitute the value of R2, R3 and R1. Okay, R2 is equal to 1000, R3 is equal to 200, and R1 is equal to 100. And we will get 2000 ohm. Okay, so 2000 ohm is the is R4, where this circuit is balanced or unbalanced, Arif? Arif? R4 is equal to 2000. So meaning that this circuit is balanced or unbalanced? Sorry?
Ya betul.
Tak dengar tanya. Tak dengar soalan.
Dengar.
Jawablah.
Balance.
Balance Okay. Saja just to make sure that you are still here and listening to my lecture. Okay, the next question for number 2 is if the value of R4 is changed to 2002 ohm, determine the current through the galvanometer Ig. Okay, if the battery voltage is 5 volts and its internal resistance is neglected, hence find the deflection of the meter if sensitivity is 10 millimeter per microamp. Okay, so when R4 is 2002 ohm, so this circuit is still balanced or unbalanced, Ahmad Lukman?
Not balance.
Balance, okay. So, the question is to find current. So how to find IG? Ahmad Nur Azim, how to find IG?
Yes, doctor.
How to find IG?
IG.
Determine the IG. How to find IG? What is the procedure? Or the steps to find IG?
Cari dia punya apa? Yang resistant tu, effective resistant.
Resistance kat mana? Resistance mana?
1 dengan 4.
1 dengan 4. 1 dengan 4.
Bukan.
1. Mana?
2, 3.
2, 3. Cari R2 and R3. Ya.
Tak sure.
Tak sure. On last Monday, you understand or not my lecture? Understand my lecture or not? Azim?
Kurang lah.
ISO you study tak? Tengok balik tak?
Ada tengok balik tapi tu lah.
Tak faham juga?
Sikit lah faham sikit.
Okay, cannot understand. Have you followed my lecture from the beginning until the end? Have you watched my video from the beginning until the end?
Saya ada skip.
Patutlah tak faham. Tengok sikit-sikit. Faham? You did not understand during my lecture and then you did not ask. Kan? And then you watch the video but you pick at certain time only. Kan? Not watch the whole video. Hasif? Okay, what's the steps to find IG? Hasif Amiluddin,
Kenapa? Ya, doktor.
What are the steps to find IG? Now we want to solve this question. Okay. We should find IG. It is the current through the galvanometer. How to find it?
IG
Ya. Ya, ada tak slide dekat you?
Ada.
I dah upload kan? Ke tak? Dah upload dah?
Dah.
Dah lah kan sebab tu you ada kan? Okay, so you can refer to your notes. You buka laptop tak ni?
Try jawab boleh tak?
Who want to answer?
Try.
Siapa tu? Afiq. Afiq
Yes,
Okay, Afiq dah tak nak dengan si Bebe kan? Okay. Try answer ni. Afiq kata lamanya nak habis silibus macam ni. Kan?
First kita calculate dia, cari dia punya VTH dulu, VTVNN. VTVNN equals to VA minus VB. Lepas tu bila dah cari VTVNN tu,
Which one is VA and which one is VB here?
sorry, maksudnya kalau dalam diagram ni VC minus VD.
VC minus
VD.
VD okay.
So kita dah dapat V-terminal dia, kemudian kita calculate dia punya R-terminal. So R-terminal ni boleh cari melalui R1 parallel dengan R3 plus R2 parallel dengan R4. And then kita lukis dia punya equivalent circuit dia.
Okay.
Dan RTH, lepas tu RG tu sama dengan RM. So daripada situ kita boleh calculate IG lah. IG tu V-terminal over R-terminal plus RM.
Okay, so what is the value for RM in this circuit?
No, dia tak ada bagi.
What is the value of RM in this circuit? Orang lain pula lah. Zaim Akil.
Okay.
What is the RM? RM in this circuit. Zaim Akil.
Ya, Doktor.
What is the RM in this circuit? As mentioned by your friend just now. What is the RM? What is the value of RM in this circuit?
M yang kat meter kan, Doktor.
Berapa?
Tak dengar ni, Doktor. Tak dengar.
Tak dengar? What is the RM? Okay, your friend, just now your friend said that we should add the R-terminal with RM. Okay, so what is the value of RM in this circuit?
Sekejap.
Okay, Aiman Haziq. What is the value of RM in this circuit? Aiman Haziq? Aiman Haziq? Kosong. Okay, how do you know?
Sebab dia cakap internal resistance is neglected.
Pandai. Siapa tu? Zaim Akil
Doktor,
Ya.
tapi tu bukan ke dia cakap pasal bateri?
And its internal resistance is neglected. Battery kan? In battery is neglected kan? Yes, for battery. So what is the value for RM here? Jom kita tengok. Okay, so the first step is to find the V-terminal. So V-terminal is also the VCD here. Okay, the terminal here. So how to find the VCD? We get the V of R3 or R1. Okay, so if you use the lower loop, so VR3 minus VR4. Okay, so that's the value of VCD. Okay, so we take out, so we use the concept of, what concept here, Sami? Nampaklah habisnya kalau, tak. Actually we are advanced, okay, with our teaching plan. So this chapter should be teach on week after your midterm break. Okay, Sami. So this is the concept of what? Sami? Sami? Sami, Abdullah, Saleh, Al-Gobi. Sami? Tak menyahut. Okay lah, Wheatstone lah. This is the concept of
Voltage divider.
voltage divider. Sebab I nak cepat jawab ni. Panggil Wheatstone. Okay, so this is the concept of voltage divider principle. So, let's say we use R1, okay? We use the upper loop. So, VR1 minus VR2, okay? You also can use the lower loop and you will get the same answer. Okay, so VR3 minus VR4. Okay, now, it seems like the R of the galvanometer is 0 or neglected. Okay, if the question did not give us the value of RG, so just assume that it is 0. So this is the method to find. Ramona, si boleh jawab punya ni. Ramona, so this is the, okay, we want to find what value here? This is, okay, 733 is the value of what? R apa?
Thevenin.
Thevenin, Okay, so I of the galvanometer is equal to V divided with R. So V is 1.1 milli divided with this R. Okay, so we get 1.5 micro. It is very small current flows through the galvanometer, but it contribute to unbalanced condition of the bridge. Okay, this is the next question. Question number 3. Given a Wheatstone bridge as shown in figure 2 with R1 is equal to 50K, R2 is equal to 10K, R3 is equal to 500 ohm, VDC is equal to 10 volt, internal resistance of the galvanometer is 100 ohm. Obtain the value of RS when the bridge is in balance. Okay, so we know the formula. R1 RS is equal to R2 R3, or R2 over R1 is equal to RS over R3. What else? Okay, so you can use any formula. They are the same. So RS is equal to this. Substitute R2 is equal to 10K, R3 is equal to 500, R1 is equal to 50K, and we get 100 ohm. This is the value of RS when the circuit is balanced or unbalanced. Shalin.
Doktor. Balance.
Balance, okay? So, and then if the value of RS is changed. Apa dia?
Macam mana nak tahu balance ke tak tu? Saya macam terlepas.
Oh, tanya tu. Siapa tanya tadi?
Okay.
Akil. Akil Ahnan, tak tukar lagi gambar hantunya. Okay. How to know? Kan soalan dia, when the bridge is in balance. Okay, now RS is unknown. RS is unknown. So the question is to find RS when the bridge is in balance. So we just use the formula for balance condition. Tahu tak Akil, the formula for balance condition?
Tahu yang R1 darab RX equal to R2 darab R3.
Lagi? Banyak kan? Okay, so you can R1 over R2 kan is equal to R3 over RS kan? RS over R3 is equal to R2 over R1. R1 over R3 is equal to R2 over RS and so on, okay? But just use the product of cross resistance. Okay, R1 RS is equal to R2 R3. Okay, Akil.
Lepas tu kalau macam contoh, kalau contoh doktor tanya apa, okay, Lita ni balance ke tak? So saya nak jawab balance ke tak tu saya tak tahu.
Okay, We can answer the question whether the bridge is balanced or not if we know all the value of R. Okay, let's say RS is given. Okay, RS is given, so we just substitute R1 RS is it equal to R2 R3? If it is equal, so balance. If R1 RS is not equal to R2 R3, so it is unbalanced. Okay, but now RS is unknown. So what is the value of RX? If when the bridge is balanced, so we just use the formula R1 RS is equal to R2 R3, and then we find what is RS. RS is equal to this. So RX is equal to 100. So to make this circuit balance, RX must equal to 100 ohm. Boleh Akil?
Boleh. Faham. Kayaknya kalau macam kita dapat value tu, kayaknya dia balance lah.
If one resistor here is unknown, okay, so then to make the circuit balance, we just use this formula. We get the R, so the RX must equal to that value, so that the circuit will balance. Okay, but if all R are given, okay, the values of all R are given, then we can test for balance condition whether the bridge is balanced or not. Okay, boleh Akil?
Boleh.
And everybody okay? Okay, then we come to B. If the value of RS is changed to 200 instead of 100 ohm, RX is equal to 200. Okay, so balance or not? Atira, balance or not? Atira hadir kan dalam kelas ni?
Ya, Doktor. Ya.
Ya. Okay, so now RS is equal to 200. Is it a balance or unbalanced?
Unbalanced.
Okay, dah tak balance kan? Okay. Even one value change in RS, the circuit will be unbalanced. Okay. So now when the circuit is unbalanced, current will flow through the Sami? Sarah. Then current will flow through the Sarah.
Ya.
Okay, the circuit now is unbalanced, then current will flow through the
Galvanometer.
Galvanometer kan? Okay. So the VCD will be something value, okay? Previously, for balance condition, VCD is the V across the galvanometer, okay? V at this terminal. Okay, during balance condition, the V at this terminal is equal to what, Sarah?
Ya.
During balance condition, in A, V at this terminal is equal to?
VAB tu ah.
V at this terminal. VDC.
97 milli.
For question number A, okay, let's say we want to know the V at this terminal. Okay, what is the value of V at this terminal? For condition A, balance condition. Zero, Betul Mas Sarah?
Betul.
Cepat yakin. Okay, so now B is unbalanced, so we want to find the VCD. VCD actually is here, okay, VCD. Mana datang C and D ni? So okay, so meaning that the V at here, this terminal, so we use apa nama ni, apa? The concept of voltage divider principle, okay? So this use the upper or the lower loop. Sarah?
Ya, doktor.
Upper loop ke lower loop? This calculation use the upper loop or the lower loop of the bridge?
Apa?
Betul. So 50k divided with 50k plus 500 and so on. Okay, so you know this concept. So the VCD, okay, the V at this terminal is equal to 97 millivolts. Okay, but we want to find the IG. Okay, we find the V Thevenin first and then the R Thevenin. So, and then R Thevenin is equal to parallel 50k and 500 and then plus with R2 parallel with Rx. Okay, and we get this value. And then IG is equal to V over R. Please add with the resistance of the galvanometer. Okay, and we will get this value 122.61 microamps. Okay, very small current flows through the galvanometer. Any question? Any question?
No, doctor.
Okay. Clear enough, right? Aisyah Kamal, faham tak? Ada soalan? Siti Aisyah Kamal? Ada soalan? Apa ni? Afiq bagi apa ni? Kenapa Afiq?
Ada orang kick saya.
Ya ke? Ya ke Afiq?
Tembel ilmu pun banyak dugaan.
Tak ada sabotaj ni. Okay, class. Now, we continue to AC bridge. AC bridge is actually apa ni? Chapter 6. Okay, chapter 6. Okay. We learn chapter 6 first. Okay, after this, maybe after midterm break, we continue tutorial 5. Tutorial 5. Tutorial 5 combines chapter 5 and 6. Okay. So after midterm break, we continue tutorial 5. Hopefully you can do it first during your midterm break or during your Hari Raya holiday. Okay, so AC bridge, we have 4 configuration of AC bridge: Maxwell, Hayes, Schering, and Wheatstone bridge. Okay. Basically, AC bridge involved with derivation. Okay, so you should understand the derivation. Yes, we have calculation, but the calculation is involve the derivation. Okay. And you should know the AC, a basic fundamental about AC circuit, which is RLC. Okay. So AC bridge, the function is alternating current bridge are used to measure inductance and capacitance. Okay. So in DC bridge, we find resistance, right? Rs. So in AC bridge, we find Lx, Cx, okay? Inductance and capacitance. The design is based on Wheatstone bridge, okay? It consists of 4 impedances and AC voltage and detector. So we have AC instead of DC in DC bridge. Of course, we have the galvanometer here. So the same equation for balance condition. Okay, so in DC circuit we have R1, R4 is equal to apa? R1, R4 is equal to
R2, R3.
R2 multiply with R3, okay, or Z1 over Z3 is equal to Z2 over Z4, okay. So now we use the term of Z. Z is impedance. Have you learned about impedance before? Have you learned about impedance? Okay, so there are four configuration of AC bridge: Maxwell, Hayes, Schering, and Wien bridge. Maxwell and Hayes bridge used to find unknown inductance, while the other two find unknown capacitance. Okay, so this is the fundamental of AC circuit. Okay, we have, instead of R, we have we can have capacitor and inductor. Itu balik, capacitor and inductor. Okay, so this is resistor, this is inductor, this is capacitor. Okay, so R in resistor, okay, can also be represented as Z. Z is impedance. Okay, Z is equal to R. Okay, so what we call impedance? Impedance can represent R, L, and C, but R represent for R only. Okay, so but the unit for impedance is ohm. Okay, Z is equal to R ohm. Okay, so for inductor, the impedance of inductance is equal to J omega L. Okay, omega is equal to 2 pi F. Have you learned this?
Lupa lah.
Pernah Have you learned this, Akil? Pernah tak? Have you learned this during your diploma ke, matrik ke? Pernah
Pernah.
Pernah. Okay, bagus. How many of you never learn this? Just say never.
Never, Doctor, never.
Ada juga Okay. Never mind. I will teach you. Okay, so Z is, okay, so if you have question, just ask me, just interrupt me, okay? Z is equal to J omega L.
Okay,
For capacitor, okay, we can convert the value of farad in capacitor to ohms, okay? But we should convert by using this formula, okay? Z is equal to 1 over J omega C, okay? For inductor, J omega L. For capacitance, J omega C. But for capacitor, 1 over J omega C, okay? So, any question for this? Say no.
No.
Any question?
So,
Okay, good. So this is Maxwell bridge. Actually, no need to memorize the configuration of each bridge. Okay. You just refer to the circuit and then you derive to find the ZX. So Maxwell bridge find unknown inductance. Okay, this inductance LX. Okay. So during balance condition, we know that Z1, Zx is equal to Z2, Z3. And then we take out Zx, Zx. Okay, Zx is equal to Z2, Z3 over Z1. Okay, now we substitute each Z with R or L or C. Okay, so we know that Zx is equal to Z2, Z3 over Z1. Now we define, okay, we define each Z. What is the definition of each Z? Okay, so now we start with Z, let's say Z1, okay, Z1 here, okay, so Z1 is the combination of the C1 and R1, okay, the parallel circuit. So we know that this is the formula for parallel circuit to find the equivalent R or equivalent Z now. So 1 over Z1, okay, is equal to 1 over R1 plus 1 over this ZC1, okay, ZC1. So 1 over R1 plus 1 over, we know that ZC is equal to 1 over J omega C, okay, is equal to 1 over R1 plus, this will become J omega C. Any question? Any question?
No.
Okay. And then we have done for Z1. We have defined Z1. How about other Z? Okay, Z2. Z2 is equal to R2. And then Z3 is equal to R3. And then how about Zx? Zx is combination of Rs and Ls. This is series circuit. Okay, so for series circuit, we just add, okay, the resistance or the impedance. Okay, so Rx is series with Lx, so we just write like this: Rx plus ZL. Okay, but we know that ZL is equal to J omega Lx. Okay, Rx plus J omega Lx. Any question? No. Any question? Akil?
No, Doctor, no.
Okay, faham eh? Okay, so now after we define, okay, the first step, okay, please memorize this step eh. I will ask you after this. This is the steps in AC bridge circuit. Okay. The first step, write balance condition and take out the Zx. Okay. The second step is to define each Z. What is Z1? What is Z2? What is Z3? What is Zx? Okay. The third step is to substitute all the Z's in the balance equation. Okay, so now we substitute all Z in this equation, balance equation, okay? So Zx is equal to Rs plus J omega Ls, okay, right here, it is equal to Z2, Z3, Z2, Z3 is equal to R2 and R3, and then divided with Z1. Okay, we know that 1 over Z1 is equal to this, so just write here 1 over R1 plus J omega C1 here. Okay. Okay, the third step is to substitute all the Z's in the balance equation. Okay, step 3. The fourth step is to expand the equation. Okay, so Rs plus J omega Ls is equal to R2 R3 divided with R1 here, and then plus R2 R3 multiply with this J omega C1. Okay, here. Okay. Okay, so the third step is to substitute all the Z and expand. Okay, and then we come to the fourth step. Okay, equate real term and imaginary terms. Okay, so this is the equation, the previous equation. After we expand the equation, now we equate the real term and imaginary terms. Okay, we combine real term with real term and imaginary term with imaginary terms. Okay, And then we equate. Okay, so now here at the left side, Rx is the real term. J omega Lx is the imaginary term. Why? Because we have J, imaginary terms. Okay. At the right side, R2 R3 over R1 is the real term. Plus, this term is imaginary term because of J here. Okay, so now we equate the right side and the left side for the real term and imaginary terms. Okay, so Rx will be equal to R2 R3 divided with R1, and J omega Lx will equal to this. Okay, so J omega Lx is equal to J omega C1 R2 R3. But okay, so please write properly. Okay, but this slide it skip that step. Okay, it just go to Ls is equal to C1 R2 R3. Okay, C1 R2 R3 and cancel this J omega and this J omega. Okay, so this is the final answer. Rs is equal to this. Ls is equal to this. Okay, so this is our target for this circuit. We want to find the unknown resistors and inductance. Okay, Rs and Lx. Okay, up to here, any question? Any question? Sami?
Doktor,
Any question?
Q tu kan? Saya tak faham yang tiba-tiba datang Q tu.
Memang sebab saya tak ajar lagi.
Oh,
Okay.
ya ke? Okay. Pelik
so,
saya.
okay, so Q is equal to what is Q? Q represent the efficiency of a given capacitor in terms of energy losses. We know that capacitor can store energy, right? Same as inductor can store energy. So capacitor store energy in its electric field. Inductor store the energy in terms of magnetic field. Kan? So we know that capacitor and inductor is energy storage element. Kan? Okay, so Q represent the efficiency of a capacitor in terms of energy losses. So higher Q is good. Okay, it indicates lower rate of energy loss. Okay, because Q reflect to energy loss. So higher Q indicates lower rate of energy loss relative to the stored energy of the capacitor. Ideal capacitor will have an infinite value of Q. Okay, meaning that no energy is lost at all in the process of storing energy. So Q is quality factor. Okay, so this is the value of Q. Q is equal to omega Ls over Rs. So we substitute Ls. Okay, C1 R2 R3, and then we substitute Rs. Rs is equal to, we just make it reverse. Okay, R2 R3 at the bottom and R1 here. Okay, we cancel out the same term and we will get, this is the final formula for Q. Okay, do not worry about the formula. You can refer to your notes during exam, right? During test. Okay, but you have to understand the concept of the derivation, the calculation of AC, meaning that reactance, okay, impedance for L and C. Okay, we go to next configuration. Okay, actually we will apply the same concept. Okay, for AC bridge circuit, we learn about derivation. Okay, the concept of series and parallel for AC circuit, right? In DC circuit we just have R. Okay, so we know how to calculate the series and parallel R. Okay, so in AC circle we have another two element which is inductor and capacitor, but the concept is the same for series and parallel circuit. Okay, but please be noted that ZL is equal to J omega L. Okay, ZC is equal to 1 over J omega C. Okay, so this is the configuration for Hess bridge circuit. No need to memorize the configuration where is the C1, R1, L. No need to memorize. Okay, we just refer to the circuit and derive. Okay, so this is the circuit. We know that Z1, Zx is equal to Z2, Z3. Okay. I think I should put okay, so we refer to this circuit. We know that okay. It's okay, never mind. So we know that Z1, Zx equal to Z2, Z3. Okay, so Z2, Z3, Z2, Z3. Okay, this is Z2, Z3. This is Z2, Z3. Z2 is equal to, okay, so please define properly. I think I should define what is Z here first before we substitute into the balance equation. Okay, so for balance, okay, the first step is to write the balance equation. For balance equation, Z2 and Z1, Zx is equal to Z2, Z3, and then the second step is to define what is the Z. It's Z. Okay, so Z1 is equal to R1 plus what? 1 over J omega C1, right? Z2 is equal to R2, Z2 is equal to R3, and then how about this? Zx is equal to Rx plus J omega Ls. Okay, so define it first. Okay, before we substitute into the balance equation. Okay, so this is Z2, Z3. We have R2 and R3, and then it is equal to Z1 multiply with Zx. Okay, so what is Zx? Zx is equal to Rx plus J omega Ls. Okay. Okay, class. Equity. So we need to write the Z, the definition for each Z. Okay, so Z1 is equal to R1 plus 1 over J omega C1. Kan? Okay. Okay, so at balance condition, my cursor ni. Okay, class. Now, please, okay, your task is to find what is Z1, Z2, Z3, and Zx, and then substitute into the balance equation. Okay, now, try it. Let's try it yourself. Try it yourself, and then please upload your answer here at chat box.
Doktor. Dalam saya punya slide ni dia ada tunjuk at balance Z1 darab ZX equal to Z2, Z3 ada.
Ada. Itu lah. I rasa macam I pernah tulis. Mana hilang? Haze. Okay, class. Actually, the notes that I have uploaded before is the latest version because I have edited here and there. Okay. Okay, but I cannot play this because I cannot use slideshow because I have recorded. I have put some audio on certain slides. Okay, never mind. Okay, so actually I have wrote the steps in derivation for RS, LS, and CS in AC bridge. Okay, the first step is to write balance equation. Okay, the next step is to define the Z's. Okay, Z1, Z2, Z3, and Z4. The third step is to substitute all equation in number 2 into number 1. Okay, substitute all Z in balance equation. The next is to expand the balance equation. Number 5 is to separate the real and imaginary terms and solve for both equations. And the last one is to find what is RS, LS, or CX. Okay, make sure there is no more unknown term in each Rx, Lx, or Cx. Okay, meaning that the last step, we must make sure that no Rx and Lx in Rx term. Okay, so no unknown term. Unknown term is Rx and Lx or Cx. Okay, so the final equation of Rx and Lx must not contain of unknown term. Okay, so so this is at balance condition. Z1 Zx is equal to Z2 Z3. Okay, Z1 is equal to R1. Actually R1 plus 1 over J omega C1, but since 1 over J is equal to minus J. Okay, understand or not? If you press your calculator, okay, 1 over J is equal to minus J. Okay, is equal to minus J. So we also can write like this, minus J divided with omega C1. Okay, and then R2 is Z2 is equal to R2, Z3 is equal to R3, and Zx is equal to Rs plus J omega Lx. Substitute the value in the balance equation. Okay, substitute all Z's in balance equation. So Z1 is equal to R1 minus J over omega C1. Okay. Okay, class, you can also write Z1 is equal to R1 plus 1 over J omega C1. Okay, you can just write like that. Okay, and then multiply with Zx. Zx is equal to Rx plus J omega Lx, and then equal to Z2 Z3 is R2 R3. Okay. In calculator, J is equal to I. Okay. ENG button. Okay. In calculator, I. Okay. J is equal to I.
Akak tak semayang Zuhur. Lupa tak ada semayang.
Okay. And then, okay, after we substitute all Z in the balance equation, okay, and then we expand this equation, okay, just multiply R1, multiply Rs, and then plus R1, plus, and so on, okay. We expand the equation, okay, we expand. So R1, Rs is here, okay, and then plus R1, okay, J omega Lx. Okay, and then minus JRX divided with omega C1, and then this minus J over omega C1 multiply with J omega LS, we will get LS over C1Y. Okay, we will get LX over C1. We cancel out the omega and omega here. Okay, and negative J multiply with J, you will get 1. Okay. No need to memorize. Yes, you can memorize, but you can just press your calculator. Minus J multiply with J is equal to 1. Or minus I multiply with I, it is equal to 1. Okay. And then we equate the real and imaginary terms. Okay, so we have R1, Rx, okay, plus Lx over C1 equal to R2, R3. Okay. This is the real term. Okay. This one plus this one is equal to this. Okay. And then the imaginary term is in the highlighted blue. Okay. So we have J omega Ls R1 minus JRS over omega C1. Okay, so we can cancel this omega. So Rx over omega C1 is equal to omega Lx R1. Okay. And we can cancel the G and G. Okay, so we solve for Lx and Rs. Okay. And we have Rx is equal to, this is Rx. Okay, we take from this. Rs is equal to omega square. Okay, omega multiply with omega and then Lx. Okay, and then R1 and then C1. So this is the final equation for Rx for this circuit. Okay, and then we substitute this Rx in this equation number 1, and we will get, finally we will get Ls equal to this. Okay, we substitute Rs that we have found here into the first equation. So R1 multiply with Rs, so Rs is equal to this omega square Ls and so on, plus Lx over C1 equal to R2 multiply with R3. Okay, what else? We expand this, and then finally we take out the Lx, okay, and we will have R2 and this. Okay. Okay, so equation number 2 is not the final equation for Rx because we have Lx in the equation. Okay, this is not the final. How to find the, how to solve for this? We substitute this Ls into this equation. So Rs is equal to omega square Ls, substitute with this and so on, and we'll get Rs. Okay, so please be noted that the final equation for Ls and Rs must not contain any unknown terms. Any unknown term. Okay, so in Ls, there is no Rx, no Lx. In Rx, there is no Rx, no Ls. Okay. Okay, and then Q is equal to omega Ls over Rs, and we substitute Ls and Rs, and we will get this. Okay. So what is important in AC bridge? What is important? You should know how to derive the unknown term, okay, for that particular circuit. Okay, no need to memorize the circuit, but you have to know how to derive the unknown term from the circuit. Okay, later we will learn about His bridge, Schering bridge. Schering and His bridge use the same concept. Okay, we just derive unknown term for that particular circuit. Okay. Any question? Can I understand? Can I understand?
Yes.
Is it too difficult?
Yes.
Huh? Yes.
Terlalu panjang.
Panjang.
Tapi
Okay.
boleh lagi.
Tapi boleh lagi?
Boleh lah.
Boleh lah. Okay. This is the important step in the derivation. Okay, because you find that it is too long. Kan? Okay. You write balance equation. You define all z's, all z's. Substitute all z's in the balance equation. After that, you expand the balance equation. You separate the real and imaginary terms and solve for that. And you take out the Rs, Ls, or Cs and make sure there is no more unknown term in each Rs, Ls, and Cs. Okay, so these steps, okay, are applied for all AC bridge circuit. Okay, all. We have 4 configuration. Okay, apply for all. Okay, so no need to match. Okay. Okay, this circuit is for Schering or His or what? You need to match, no need to memorize the circuit. Okay, you just derive for unknown term for that particular circuit. Before I stop the recording, any question? No? Can understand well? Never mind, you can watch my video later. You can try tutorial 5 and we also will discuss tutorial 5 after the midterm break. Don't forget, tomorrow we have
exam.